Hello, everyone. Thank you very much for sharing this great moment for us. We are Team Platypus. It's Sammy, Will, Felipe, and myself, Peter. And we have been building a web browser for the last 10 days. Why a web browser? Because everyone said it's going to be insanely hard. And we just love the idea of facing the biggest, most complex challenge as our final project. And probably just like that you can do it. So we just wanted to do it. Also, for the first 10 weeks, we have been created a lot of web pages which are interacting with the browser. Yet we felt our understanding of a browser is very limited. So it was just a perfect excuse to extend our knowledge in coding and definitely extend our knowledge in how the web works. And also, it's a really great project because you can get a skeleton done relatively easily and you can just keep adding more and more function into it.
So, to pass or not to pass? At the start of our project, we asked ourselves, did we want to write all of it or did we want to rely on any libraries? Now, a library is code that has been written by somebody else. For example, all web browsers use something called a parser. A parser will receive a string of HTML code. Now, when you check out a website, you don't want to see the HTML code. You want to see the important things in between the HTML. So what does a parser do? A parser will take that string of HTML code and then split it into chunks of separate tags that they can eventually render as elements that will appear on the web page. So before we started, we did a lot of research, and everything was telling us not to build your own parser or renderer. They were already available, which we could have just taken and put in our project, which would have saved us a lot of time. But we thought, nah. Let's just build our own. And we did. We built it with Node.js, sorry. And we did use one library to create our super cool interface.
Thank you, Sammy. Hi, everyone. So as Sammy said, we built our parser. The next feature that we built was a renderer. What it does is that it gets the result from the parser, and it just displays the text on the screen, as you can see on the right. Are you impressed? Yes. You should be. OK. The next feature that we implemented was the requester. What it does is that you go into your very modern computer here. You type a random website, such as web browser test. And that goes into a server that looks like a fridge. But let's just think about the server as a big old computer full of information. And it returns you that information. And in our browser, it goes through the parser and then the renderer. And what you get is this very sophisticated first fully done product that you see here. Yes, I know. Amazing, isn't it? It is. Right. The library that Sammy was talking about it doesn't take care of any logic in our browser. All it does is take care of the graphical interface, which you can see there. It's beautiful, isn't it? Yeah. There you go. Following that, we implemented the ability to visit links. That was a huge success. What we did was we attached a number next to each link on the website. And you go into the address bar, type in the number, and then you get the content from that link specifically. Following that, we added a styling. So every header is in bold, basically. And every link is underscored and blue as a good old 90s browser, as you can see there. Amazing. Finally, so this one, have you ever seen this? You probably don't remember that. That is because browsers, what they do is when you type a URL such as google.com, what it does is that it automatically, in our case, because we're in the UK, it automatically redirects you to another URL, which is google.co.uk. So you don't get to see this anymore, huh? And our browser is able to deal with that. Yeah. Yes. Yes. Now, I'm afraid we have a cringy video here for you. So I hope you're ready to be entertained. Okay. Wonderful.
Hey guys, what's up?
Not much. We are trying to read the latest news of Love Island, but this browser sucks.
Wouldn't it be cool if you make your own browser?
Why not?
Nah, you crazy.
No, we can. Let's just do it. Hey guys, what are you doing?
Come check out the browser we built.
Wow, that's so cool. What's his name? Platypus.
This is so quick and barely contain excitement.
Let me show you guys some things.
Oh my god, Jolly Pizza started on Love Island.
Wow, how to follow that. So what were the things that we found hard as we were doing this project? I can really think of two main categories, and the first one was we wanted to get the order of things right. So when you're writing software, you can have everything run in a big sequence, but you can also have some things happen now, some things wait until something happens later. You can have bits of code running in parallel. For our browser, we realized that when it started up, we wanted to have an empty screen. We wanted to have an address bar waiting for the user to type in an address. But we didn't want, for example, the parser to run right away, because if that happened, it's not going to have any data, it's going to get an error, maybe the whole thing crashes. So we learned a little bit about this on the course, how to deal with these sorts of situations, but in this project, the number of situations where that arose and the complexity of them was something none of us had ever dealt with before. So it was even harder as well, because we dealt with a concept called recursion, which is where bits of your program sort of rerun themselves over and over and over again, and then just the sequence is confusing. And we were, you know, when you get a web page back, we had hundreds, sometimes thousands, maybe tens of thousands, an exaggeration, but huge numbers of things that all had to happen exactly in sequence, one after the other, each one not starting until the thing before had finished. So it was really tough. The second thing was anticipating the crazy ways that people would write in HTML and write their websites. So we started out with a browser that was just capable of seeing that. So we put that on the internet, a website that was just that. And this is people who don't know, that's a paragraph tag. What's inside it is text that's going to be just appear as text on the screen. And first of all, it could do that. If you gave it anything else, it would break. And then after that, we put a tag inside of a tag. And that worked. It was perfectly symmetrical. Anything that wasn't symmetrical wasn't happy with it. And then we ended up with something like this, which is getting a little bit more exciting. We eventually ended up at a place where it was sort of like whack-a-mole. Like we would go into the browser, realize that something wasn't coming out the way we wanted it to, go and find out what it was, isolate it, and then we'd fix that, and then we'd go and visit another website, and oh God, there's another thing, and it just carries on for a very long time. This was really hard with links, because sort of with the rest of it, we could tolerate a little bit of, you know, some things not looking quite right, but with links, they really had to work. And this is what a link should look like. This is a pretty A tag. It's got the address, it's got the link, the text, which will be blue and underlined. That was working for the most part, and then we realized a few days ago, we were on the BBC website, like, oh, there's some links here which aren't coming out quite right. Let's go and crack open the source code and take a look. What did we find? That is one link. That is a single link. There were dozens of these, horrible, ugly, evil things. Don't feel bad if you can't spot the content in there, because at the time our renderer couldn't either. But here it is. We've highlighted it for you, 3 of them. Yeah, I think those were the really hard things, and Peter's going to talk now about how we dealt with difficult stuff.
So how did we overcome all these challenges? Well, with lots of beer. But how did we work through them? We use test-driven development, what we learned here, which means that first you are writing your test. It helps you to identify what you are trying to achieve, and also you can be always reassured that whatever you implement to your program, everything is still functioning in the way you want it. We use a lot of different debugging techniques, which basically helps you to identify where your problems are, so you can solve them relatively easy after that you identified what your exact problem is. We also done a little of research, experimenting, and we try to always work very closely to each other, listen to each individual's idea carefully, because at the end, that's what it paid off, and that's where we get to. We learned a lot, but even more, we had a lot of fun. Thank you very much.